In this demonstration, we are going to show how to analyze experimental model test data using VMAP. A little description about the experiment. This is a simple cantilever beam which is fixed at one end, and impact testing was performed on that. And we have stimulus data, response data, frequency response functions, coherence, and so on. And all of the acquisition was done using VMAP. But in this section, we will import that data and do analysis on that data. Once we complete looking at the analysis of test data, we will bring in finite element analysis results within VMAP for the same cantilever beam and look at mode shapes using finite element analysis data. Then the next step would be to do a correlation study between the test data and finite element analysis data. So let's get started. So there are two sections here, test geometry and finite element analysis geometry. So let me import both the test data and finite element analysis data. The first step is to load the geometry files, which will go into this section. And you can see that this has become grayed, which means I cannot import data in UFF format, which is understood by VMAP given the file extensions that are provided in the geometry section. I specify the folder where the test data is available. Now I can also upload the finite element analysis results, geometry and data files. It could be in any other folder, but for convenience, we have already put the files in the same folder. This is geometry, which matches with the same geometry files that are provided for test also. Now the results file here. So now we have the FEA data files. When I click OK, we have a window which is all set up for a correlation study between test and simulation data. So let me take a few steps backward and move to just looking at the test data to start with. So the default, we would get the mode indicator functions. I would like to show various other signals that are available here, stimulus and response. So this was a beam. So the test model is essentially a beam which has these markers which show the 7 points at which triaxial accelerometers are mounted, and the experimental model test was performed by impact testing. Now these numbers, node 1 to 7, essentially signify the 7 nodes or locations where the sensors were mounted. So stimulus, response, you can look at all the 7 or one at a time or all of them again. We can look at FFTs of the stimulus and response, frequency response function, amplitude and phase. We can look at coherence. So before proceeding with analysis, I would look at how good the coherence is. You would expect that it is close to 0. It's in log scale, near to resonances like here and here, say this frequency here, this one here. And it will drop down to 0 at or to a negative number since it's in log scale in regions where you have a 0 in the FRF. Likewise, I can continue this analysis for other nodes as well.